All right, this is the last way you could see a substitution problem. As you are looking at this system of equation, neither x nor y is by itself, and this is where the problem starts leaning on your math facts. So when you have a problem like this, you need to solve for x or y in one of the equations. It doesn't matter what equation, it doesn't matter what variable you solve for. What is often going to happen is that there is usually one variable that's easier to solve for that doesn't give you decimals or fractions. If you are looking at this and you're like, hey, no matter what I do, it's going to be a mess, this is a hint in the problem itself saying, hey, substitution isn't the best or most efficient way to solve this problem. Could you get the same answers and just use the calculator's fraction function? Yes, that is perfectly fine as well. So, as we are looking at these problems, our options are to solve for x or y. Now, if you don't know your math facts, choose a letter that looks easy to use and go from there. If you do have strong math facts, you can start picking out, like in this top equation, hey, I see a 3 and a 4 as the coefficients of my variables. Those are not numbers that go into other numbers easily. I don't want to use those. So then I would look at my bottom equation, and I have 5 and 10, and oh, neat, 5 goes into 10. So I am going to solve this bottom equation for x. As I start doing this, and I've made this decision, the same way we convert out of standard form, how we convert out of standard form is how we would do this. Again, I am using my inverse operations. I see plus 10. I subtract 10 from both sides of the equation. You see me already being used to only ever using x's, right? Y's. That 5x needs to drop down, and I'm left with negative 10y plus 15. I would divide everything by 5, and I get x is equal to negative 2y plus 3. Okay, now I have one of my variables solved for. I can substitute negative 2y plus 3 in for x. How did I know that it was being substituted in for x? Because right there it says x equals. So I write 3. Instead of x, we substitute it in. Negative 2y plus 3. Notice as I'm substituting in, the other letter disappears. This is what we want. I want one equation with one variable. I would go through and start solving. I start by distributing. Notice I have two y's on the same side of the equation. I'm going to combine my like terms. Negative 6 plus 4 is negative 2. And now I have a two-step equation. I see plus 9. I'm going to subtract 9 from both sides. Okay, now I did all that and we got y is equal to 1. Now again, it doesn't matter which one you choose. I have, in fact, 4 options I can look at. 3 options I can choose from to substitute y equals 1 into the equation. Choose option 3. Option 3 is the best. I can say option 3 is the best because it says x equals. I don't have to do anything else besides plug in a number and use my calculator to figure out what x is equal to. So before I knew x was equal to negative 2y plus 3, I substitute in negative 1. Sorry, I substitute in, that should be a positive 1. Right, look over here, that is a positive 1. I need to make sure those signs are the same. Negative 2 times 1 is negative 2. Negative 2 plus 3 is 1. So in this problem, I get x equals 1, y equals 1. That is my solution. Now, if you are looking at this problem and you're going, wow, I don't like this. I wish there was an easier way. Well, the neat thing is there's another method we'll talk about when I come back. This is using elimination, where I can add the equations together in such a way that something eliminates, and it makes a problem that looks like this a little bit simpler versus solve for a variable, substitute in, solve for that variable, get an answer, plug it back in to do all this work. For right now, though, the only tool you're going to have is substitution. So if you have an equation like this, here's how you solve a system of equations using substitution.